That's okay, fine. Any question? We shall see that how disk retrieval is done. Suppose during the execution of a program, there is a need to disk IO. Disk stores information and we want to update some information or we want to get the information. How it is done. So we shall see how disk IO means input output is done. In the disk input output, value of some block can be updated or can be written. Update or can be read. Update or read block on this. One of the method is program driven IO. In the program driven IO, request is sent to disk. Repeated check is made whether work is done. And when work is over, we proceed with normal execution. So CPU is in busy wait condition during IO. Is it correct? CPU is constantly not doing any work when IO is going on, and it is simply checking whether IO is complete or not. So it is called a program driven IO. Let us see what is done. Job, ready, service, and interval. Suppose there is a job A which is ready at time t equal to 0 for the service, and it requires 60 units of the execution time and 80 units of the service time, IO time, 80 units of the IO, and further 40 units of execution. 60, 80, 40 means 60 units of execution, 80 units of IO, and 40 units of execution after the IO. Now, what job B it is ready at time t equal to 10. It requires 90 unit of execution. So what will happen? Job A will be allotted CPU from time t equal to 0 to 180. 0 to 60, it is in run state. 60 to 140, it is in blocked state. And 140 to 180, it is again in run state. And job B will be executing from 180 to 270. During 80, 60 to 80, CPU is not doing any computation. It is simply checking whether work is over or not. Yes, Niranjan. It is simply checking whether work is over or not. So it is in a busy wait condition. Is the concept of program driven IO is clear, or ask your doubts? Any doubt on program driven IO? Ask question. No. That is the fault of program driven IO. We cannot start at time t equal to 60. We shall talk about one scheme in which t will start at time t equal to 60. But at present, not. Any doubt? Any more doubt? Request is sent to disk. Request is sent to disk. Then work is over. Disk sends is interrupt, message, or signal. Sends a signal. So CPU comes to know that the work is over. Now we shall see how this is getting executed. Zero to 70, and it will execute from 70 to 160. And then it will further execute from no, I will Nilanjan, it is 70 only. There is a reason behind it. Then it will further execute from 160 to 210. Is it correct? Now, normal execution from 0 to 60. Then I will tell you, then I am telling you. Then what is to be done? This information is sent to disk. Then it is sent to disk. This is getting done from t equal to 60 to 70. Is it correct? T equal to 70 to 130. Disk carries the work. At t equal to 130, signal or interrupt is sent that work is over. Is it correct? But the execution of some other job was going on. Just wait. Subham, it is correct. It is 130 only. And execution of some other job was going on. It is over at time t equal to 160. At t equal to 160, CPU picks information from disk. So t equal to 160 to 170, CPU picks information from disk. And 170 to 210, 40 unit of normal execution is done. I will explain to you. Let us come here. 80 units of IU means what? 80 units of IU means what? 10 unit time to send information to disk. Sixty units of the disk operation. And 10 unit time CPU will take to pick the information from the disk, after the disk operation, transfer the information to main memory. Is it correct? This is how the 80 units of the IO will mean. So job 10 unit of the time CPU will take to carry the information to the disk. What is to be done? So disk operation is going in parallel with CPU execution of some other job. Is it correct? Any doubt? Gyan, Subham, any doubt? Any doubt on interrupt driven IO? Any question? Why B will? You see, the execution of the B is going on now. Execution of the B is 90 unit time. It is undergoing from 70 to 160. Is it correct? Nilanjan, your question is not clear. You see, job needs disk IO of 80 unit time. So disk IO of 80 unit time basically means 10 plus 60 plus 10. 10 unit time, CPU sends the information to disk what is to be done. Then for 60 unit of the time, disk carries out the operation. And then further 10 units of the time, the information is transmitted from disk to CPU. Is it correct? Dipankar, is your question clear? Yes. Prabhat, in last scheme program driven IO, what is the problem? You see, let us, yes, technically speaking, it could have started. Technically speaking, it could have started. Is it correct? But why to start? Let us complete the job A first. Is it correct? Why to unnecessarily preempt a job? Prabhat, is your doubt clear? Nilanjan, your question is not clear. Nilanjan, your question is not clear. We are not showing disk to which time in interval time? You see, why we should write 70 to 130? We are writing 70 to 160 in the execution of B, and 70 to 130 disk IO is going on. Where should I write? You tell me. Where to write 70 to 130? Yes. So here we have written interval from the point of view of CPU. Interval for CPU, and we can write interval for disk. And disk is doing the work from 70 to 130. Is it correct? Nilanjan, are you satisfied? You could have written it. Any doubt? Now, third is direct memory access. We shall see. What is to be written, what is to be done is written somewhere in the main memory. Disk picks and the execution of some other job can be done by CPU. Whatever is to be done is written somewhere in main memory. the information and CPU can do execution of some other work. Now, this picks up the information from the main memory. What is to be done? This carries out the required work. Disk transfers the information into main memory. Is it correct? So this is A, this is P, this is Q, this is R. Is it correct? Now, P and R, CPU is doing, can do some other job during PQR. Correct? Now, we shall see what will happen in this case. During 0 to 60, it will execute, and from 60 to 150, it will execute. Then from 150 to 190, this will execute. Is it correct? During 60 to 70, disk picks up the information (70 to 130). Disk operations are going on. As we have seen that disk operation do not bother CPU. And 130 to 140, disk transfers the information to main memory. Yes. Now, 60 to 70 and 130 to 140, both CPU and disk are using main memory. Why CPU is using? Because CPU is executing some other job. Hence CPU is using main memory. And why disk is using? Because disk is trying to, whatever information disk collected, it is putting into the main memory. Is it correct? So for this, maybe that some special hardware is needed or a special method of the operation is needed. Hence, they work, rather I should say disk work in cycle stealing mode. Is it correct? Is your doubt clear? I will again repeat it with the help of an example. Ask your doubt. Some special hardware is there. Is it correct? Niranjan, special hardware is there or special software is there which can make it possible. Yes. Cycle stealing mode means during the time when CPU is not accessing main memory, at that time disk will access the main memory. Is it correct? Yes. Cycle stealing mode means this. What about the 130 to 140? I have already written 130 to 140. Disk will put the information into the main memory that what has been done. Is it correct? Yes. One forty to 150. 140 to 150. Execution of some other job is going on, Deepankar. No. During execution, many times computations are done, addition is done, subtraction is done. Suppose we are accessing P equal to Q plus R. P and Q are available in main memory. So R, Q and R are available in main memory. So they are brought to CPU registers. Then their addition is done. Maybe that when the addition of two numbers is getting done, at that time CPU is not using the main memory. During that time, disk can use the main memory. Is it clear to you? You see, Harshvardhan, 60 to 70 CPU is working for some other job. But how the work of the CPU is done? CPU wants to compute P equal to Q plus R. So the value of Q and R is in the main memory. Afterwards, the addition part is getting done. During the addition part, CPU is not using main memory. At that time, disk can use the main memory. Harshvardhan, is your doubt clear? What is your doubt? Yes. What is cycle stealing mode means? CPU will be executing job B and CPU is doing computation of Q plus R and storing P. So value of Q and R will be taken from the main memory to CPU register. Then their addition part will be done. Then the storage into P will be done. Do you understand? When Q and R are getting added, then when Q and R are getting added, during that time, disk can do its operations. Is your doubt clear? Krishna, is your doubt clear? CPU is working for B from 60 to 70, but all the time it is not using the main memory. Yes, Sivendra, it could be large. In this case, it can be large because it is not getting full access to the main memory, but for the time being, we ignore it. Whatever you are saying is correct. That is correct. Fully correct, Sai Krishna. Any doubt? Whatever Sivendra is telling, fully correct. Normal time taken by the disk is 10 unit. But when it will work in cycle steering mode, it will increase. Any doubt now? Any question? May I proceed? What is going on 140 to 150 for the job A? 140 to 140 to 150, job A is in ready state, Roy. During 140 to 150, job is in ready state. But since CPU is executing some other job, it is not working. Now, let us see this example. Job P requires 100 units of the service and job Q requires 20 units of the service. It is ready at time t equal to 20 and it requires 40 units of the service. Job A will continue from time t equal to 0 to 20. It correct? It is shortest remaining time next. Another job comes which require 40 units of the service. It will continue from 20. At 50, it will make a check that some other job has come. But at 50, its time will be 10 and its remaining time will be 10. So it will continue from 20 to 60. Is it correct? And 60 to 70, this job will continue. Then from 70 to 150, this job will be continuing. As such, there is no problem. Do you understand? It is simply shortest remaining time next. Any problem? I am writing. Just see. Job P will continue from 0 to 20 and from 20 to 40. Again, it will continue. Job R has come now. It requires 40 unit memory. So swap out of job P will take place. 40 to 45, job B is swapped out. Means memory given to this is freed. And the execution of the R will continue from 45 to 55. And from 55 to remaining time 75, this will continue. And from 80 to 160, 80 to 160, this will continue. Is it clear? No, swapped out with R doesn't mean that. Means the values of the variables of the job P is transferred to disk because total memory is 100. Job Q memory is already in the disk. Now the execution of the job R has to start. Is it correct? The execution of the job R has to start. So the values of the variables of the job P are to be removed from the main memory. Swapped out means main memory to disk. Because the reason was this, that total memory is 100. Job P needs 40 memory and job Q also needs 40 memory. Till that time, conflict have not started. Do you understand? That is correct. Correct. That is why 20 to 25 job P swapped out was not required. The reason? Because total memory need of P and Q is less than 100. That is why 20 to 25 job P was not swapped out. When job R came, then the job P was swapped out. Any doubt into this? Please ask your doubt. Okay, you see, job P is work from 0 to 20. Because job Q is over. Yes, as it is over. And rather, it is not required also. Because the total memory of P and Q is less than 80. And Harshvardhan, you are also told fully correct. As it is over, it need not to be swapped out. It need not to be swapped out. So that is what we are doing it. 75 to 80 job P is swapped in. Fully correct, Vikas. Ask your doubt now. The reason is this, that later on we need Q. Because when the work is over, when R is over, we will continue with Q, not with R. That is why no need to swap out Q. Prabhat, is it clear to you? Dipankar, it is not clear. If Q need memory at 61, Q was already giving 40 unit of memory. If Q need memory 61, we have to see this. Dipankar, we have to see this. Yes, if Q needs 61, we have to do swapping out of P at T equal to 20. Fully correct. Dipankar, and then yes, fully correct. Dipankar is fully correct. If Q needs 61 unit of the memory, then P will be swapped out first, 20 to 25. Then Q will be working from 25 to 40. It is fully correct. Yes, fully correct. Dipankar and Prabhakar correct. You see, 40 to 45, swap out of P, and execution of R is going on. Do you understand it? See the difference between program driven IO and DMA. R needs memory. At present, memory is not free. Yes, Gyan is correct. We should step in. Gyan is correct and I was wrong. Gyan is correct. Gyan is correct. 60. Is it correct? Yes. Gyan was correct. I was wrong. Any doubt? Any doubt? What is happening in DMA? We shall swap out from 40 to 45 job P. 40 to 45 execution of job R is not going on. I made a mistake. Execution of Q is going on because R has not been given that much memory. Is your doubt clear? Harshvardhan, your question is not clear to me. You can send your question in mail. Any doubt? Next week, what probably exams will be there? Because, yes, fully correct. Because job are arrived at time t equal to 40 only, Deepankar. Why we should swap out P in advance? We were not knowing that the job R will come, Deepankar. Deepankar, is your doubt clear? Class is over. I am sending the notes.